Hope you guys are hello everybody. Hope you guys are doing well. So continuing on our journey, today we will be starting with another chapter. So basically, we'll try to cover as much as SQL as possible. Okay, so let me have this thing. Okay, so the first thing that we are going to see is basically something called as ER modeling, right? So this basically means entity relationship, right? Now, what is this? So whenever you go to an architect, right, before uh, before making the actual house, a blueprint is made. So that blueprint is nothing but uh, referred to as a ER diagram, right? This is basically more of a theoretical, right? uh, Theoretical diagram. Now it has two words. So basically E is for entity and R is for relationship, right? Now we'll see. Now what is ER? So ER modeling is a database design technique to visually describe the structure of a database, right? So basically we are going to describe the structure visually, like what are my rows, what are my columns. Remember we are talking about RDBMS, right? Our database management system is uh, going to be RDBMS, right? Relational database management system. That means our data is going to be in the form of relations, or in other words it is going to be in the form of rows and columns, right? Now this is like a blueprint. Now this is a sketch to indicate how we are going to make the database, what our rows will be, what our columns will be. Therefore, before that, we do need to have a layout, right? Now, what is this relationship, right? So basically, there won't be a single, right? It is it is impossible to store all the data in one single table, right? So what we would be doing is, to ease out, we would be storing our data in different tables, right? So instead of having a single table here, we'll have two tables. So this is table one. So yeah, say this is table one, then you have table 2 and so on and so forth, right? So basically we are going to have more than one table. Now these two tables need to be related to each other, right? So we need to form some sort of relation between these two tables, right? This relationship between the two table is nothing but given by relation, right? Now there are different types of relation. It can be one to one, it can be many to many, it can be one to many, and so on. Now entity, so entity is basically this, the table is going to represent entity, right? So table is the entity here. Now then is basically the attribute, right? So when we say the attribute is basically the uh, okay, so this is the table, right? So suppose this is the table. So this is our table here. Now what is the attribute? Now this table is nothing but given by our entity. The attributes are basically the different columns, right? Basically the, for example, there is one column for student ID, one column for student name, and so on and so forth, right? These are basically called as my attributes. So the column is nothing but the attribute. So column is the attribute, right? The relationship is basically how these tables are related to each other, right? So I have, this is table 1, I have, this is table 1, and then I have table 2, right? So how these tables are related to each other, this is basically given by relationship, right? So the how these two tables are related, this is nothing but given by a relation, right? Now since we are talking about theoretical, right, so basically we can represent the tables in different format and shapes, right? Now there are shapes to represent. Now for example, if it is an entity, then we represent it by a rectangular shape, right? Now basically this is going to indicate that this is our table. If it's a attribute, then we are going to give it Okay, if it's an attribute, then we are going to have it by ellipse, right? If it's a diamond, then we say that is a relationship, right? Then it's a line. There are different types of lines and relationship as well, right? So that is how, more or less, how our ER modeling is going to work. Now this is basically a rough sketch out, right? So there is no point. Now we will try to understand the different types of relationship, or the different types of relations, when we actually start building our relational model, right? Now is the time when we think about the relational model, right? So this is our core topic, relational model, or RDBMS, right? Now what is a relation? So relation is made up of two things. So if it's a relation, then we have two basic things. One is basically something called as a relation instance, relation schema. First is something called as a relation schema, and the other one is basically called as a relation instance, right? Now this relation schema is nothing but our uh, this is our columns, and the relational instance is nothing but our table, right? So our relational model consists of two things. One is the relational schema and the relational instance. So the relation schema is nothing but the columns, and the relational instance is our table, right? Now relational schema, relational name of each field. So we can further break down into relational commas into further subtypes, right? For example, you're also going to mention the domain name, right? Domain is basically what values are associated with, right? And so on and so forth, right? Now an instance of a relation, so an instance is also called as a, so this instance can also be named as, so if this is an instance, right? Okay, let's say if this is an instance, we can also call this instance, or uh, what do you say, we can also say this, like this is our uh, an instance of a relation is a set of tuples, right? So basically this, so okay, so what is it, table has different rows, right? So each rows can be, okay, so what he's trying to say is a relation instance can be said, can be, a relational instance can be uh, so a relation of a relational instance is basically a set of tuples, right? So this is a set of tuples, also called as records, right? Okay, so if we try to understand the diagram, how it is going to look. So first is basically our table, right? So this is the table. Now this table is nothing but our what do you say, relation, right? So this is my relational instance. Now this instance has different columns, right? So I have this column 1, this column 2, this is column 3. Now these columns are uh, so these columns are nothing but our uh, relational schema, right? Okay, now what further they consist, further they consist of different domain names. A domain basically mentions like the type, I mean, for example, it can be integer, it can be string, it can be character, and so on and so forth, right? Now uh, now basically we need to understand how to create a relation, right? So basically, okay, and then we also said that these rows, or these rows, are nothing but So this is row 1, right? So if this is my row 1, so this is nothing but called as a tuple. So you have a relational instance. So this relational instance is basically our table. Then we have a relational schema that consists of columns, right? And columns consist of domain names and any uh, and field name, right? Or these are also called as attributes, right? Now each relational instance consists of set of tuples or relations, set of tuples or relations, which are nothing but our records. So now our goal is basically to uh, identify and start our record, right? Okay, so now let's go back. Okay, let's okay. Okay, let's hide the sidebar. Let's further classify things, right? Okay, so now first thing is basically to create a. So basically now we are going to creating and modifying relations, right, using SQL. Now the SQL is basically the standard language, right? So first thing is basically we need to uh, yeah, so we need to start MySQL. So the way, yeah, so now let's open our, okay, now we need our window capture maybe. No, we don't. Oh, now let's add this thing. So let's open terminal. Now we are going to do oh no, wait. Let's go back and so I'm starting by RDBMS right now. I don't know why is I get this error. Let's paste it though. Okay, so now brew service start. My service MySQL already started. Use brew services. Let's restart. Okay, and then now let us list it. So if I have, okay, so I have MySQL being running. So I have two things which are started. Why Jupyter Lab has started. Okay, then that is okay. So now let's open our VS Code. So let's go Visual Studio Code. Let's close this thing. Let's have a, what we can do is, do ls and let's make a directory for SQL only, and then let's go to that directory. Now let's list anything. Now let's start our VS Code over here. If I quit this, let's open Visual Studio, and then let's, oh no, uh, is it because it's installed over there? Let's open a new window. Let's open the repository MySQL. Let's open this. Let's have our, right now we have a lot of things here. I have my test. Let's do a new, yeah, so I already have that. So let's create a new, uh, the password was G1, I remember. Let's, oh, so the collection has been made. Now, I need to create a new, okay, so what I can do is, let's, let's get rid of this. And then, no, let's remove all of this. Let's do a create connect. So the root password is what I need to enter. Let's, now in this, okay, so first is basically I need to, okay, so what I can do here is, so this is select star. First I need to create a database, right? So I have to create, so I'm going to do create database, and then the name is what I'm going to enter. Okay, so I'm going to create database. Wait, what's the error? Let's have the, with create, yeah. So I'm going to create my database. So okay, let's simultaneously think what we are trying to do. So first is I need to have a database, right? In this database is where I'm going to have my records, right? The tables being created. So now I have my database created. Let's now let's do use. When we say use, we are going to mention that which database we are running. So I'm doing use test. So now this is an indication that I'm in my test database. So now I'm going to create. So I need to do create. Let's create the table. So create table. What happened? So first is create table and then table name. So this is, remember this is here I'm just modifying my schema, right? Okay, let's come back again. So when we do, so I have done create table, right? So I have created this table. Now inside this table, so what we said that we have a uh, wait. This is our instance, right? So we need to create this instance. This instance has been created. Okay. Now once the instance has been created, then inside the instance, we need to add the schema. So we are going to add the schemas in here. Is basically the columns, right? So I'm done create table students, and then I'm going to do SID is and then uh, now I'm going to have my name. No, wait. And then the domain name also has to be given back. So even this is character. I guess by default, uh, there is a, and so this is 30. For the time being, we are giving as much as big as possible. And then I have login, right? Remember the way I'm going to write it here is how is my, so I have character, and then I'm going to do 30 again. Then I have a roll number, right? So I can do roll underscore number. This is going to be integer, right? And then I have GPA. So let's say this is GPA and this is real. Now let's just run this. Now to CVR table, right? What we are going to do, we're going to do select all columns from now students. Students is the table that we are going to run. So this, okay, let's get rid of this thing and let's have this little bit. Okay, so this is some message over like, okay, right now we don't need this thing. So now we have the table. This is the domain name. So I have SID is a string. I have login, roll number, and jabal, that is real, right? Now uh, let's come back. So now what I uh, so basically I have done my I've created my table and I have an SID. This is my columns, right? So my attributes are there. Now what I need to do is I need to add the tuples inside this, right? So basically we need to add in tuples inside this. The way to add tuples is uh, now we are going to insert, right? So I'm going to insert into the first. So basically every uh so I'm going to insert into, so basically this is my column name, right? So column name is okay. So first I need to do insert into, and then I need to have the column name. uh, so it's okay, I guess it's insert into which table. Okay, so I need to have the table name here. It's going to be students, and then my column, I guess, is going to come here. So column is my SID, then I have name, then I have login, and then I have a row number, and then I have GPA. Right now I haven't given the values, right? So inside this I'm going to insert values, and then now is when I need to mention my first. Okay, so my SID is a character, right? So it's going to be I3 anything. You can have a name, then I can have a, the thing is SID is character. Okay, and then again I have a login, right? So say this is some email. Basically this is Smith at some specific ID. It's going to be at e.com, and then I'm going to have a number, say, which is 18, and then GPA, that is 3.2. And let's run this. Basically I'm adding a single row right now. Let's see what our how our table is looking. So I'm going to just do students. Let's run this. So this is the first row that I've inserted in my table, right? We'll see this later on, cost and everything. Okay, now if I want to insert multiple, right? So what if I want to, so I'm doing this is only one column, right? So if I, sorry, this is only one row. What if I have this select into students, and now I'm going to mention my column, right? SID, name, login, roll number, GPA, and then now is my values. So this is my first tuple. Define, so how it's define the values to be used into an insert. So I said 10. What if it's multiple values? So right now this is only value, right? So each value, okay, so every value is going to be a tuple, right? So I can do, this is say G1, and then say this is G1 at xyz.com. Then I have say okay, let's have a common 10, 20. Now what if I want another thing? Just separate it by a comma, and have, okay, what I can do is I can have this values down, and instead of having it on the same line, let's have another tuple. So this is a 20. This is Harsh. And then this is Harsh at the rate xy.com. And then I have 10, 20, right? And to terminate this, I'm going to use colon. Let's run the AR into. Now there is saying that there's an error when I'm doing. So select into students. I have an SID, a name, login. Also, there is something that is. Oh yeah, I missed. This is 10 G1. Wait. So if I run this, if I it's 10 G1. This is a space there. Let's save SID name one. Yeah, is my table name SID name. This is mostly going to be. Oh yeah, this has to be insert, right? This, oh, it was saying I was reading this as insert. Yeah, now I've added two, so it says basically it's coming, right? 2 rows affected. Now let's do select all, and then let's have the table names. Okay, let's run this. Yeah, so now it's, so I have come here, right? Okay, now what if you want to update a record, right? We can modify the columns of an in an existing row using, so you can delete, right? So what if I want to delete entire, or if I do want to, so you either, yeah, so I just want to delete something, so let's work on delete. So this is, so if I do delete, this is again delete, and what is the table name? Table from. Now what I want to delete is, uh, let's say this is an alias, right? And where is, where the s dot name is a, do I have a name, right? I want to get rid of that. So one row is affected. Now if I do select star for students, right? So that G1 row is gone. One more, and if what if I want to update this? So let's try to update the record. So we'll do update, and then, so which table? So this is student as, uh, from table. Also update. Yeah, it's table name alias is as, right? Now I can say, Now set s dot name to Smith. I can add in the condition, right? So where s dot, so my alias is small, right? So s dot name is Smith in capitals. So let's run this, and then now if I do a select this has to be from student. Okay, so yeah, right now what I did is I just changed the S Smith from caps. Oh, what is this? Yeah, I just changed the. So this is basically adding multiple values, right? You do insert into students, and then you do SID name, login, roll number, then you pass in the GPA, right? So this is basically my columns, and in those columns the values that I'm entering. Now integrity constraints, right? We can add certain uh, constraint as well. Now there is something called as primary and foreign key, right? We haven't studied that constraint. This is basically when we have more than one table, right? We'll see when to have a primary key, when to have a foreign key, so you can enforce into some constraints as well. Okay, we haven't seen transacts, right? So yeah, you can what we can do is we can just have an error diagram, and then from that we can derive our table. Let's yeah, I can update this as well. So if I want to update this, so let's update. So we are going to use an alias, right? The thing is is dot login. So we are going to set that as harsh at xyz.com, and my condition is where is where dot name, sorry, h dot login is at xy.com. Let's update. Now test dot student. So, okay, update student is set. This has to be an exact match, right? Harsh at xy dot test dot student doesn't exist, so there is no deciding on this. X at the rate login. Some date tables to test error. Okay, I guess what to do is this running? Okay, let's come down. Oh yeah, this is students table name is, and then let's have this thing being pasted here. So let's have this. So now even this is updated, right? To com. Okay, perfect. Now the next topic, we haven't seen about views and everything, right? We'll see later on what are views, why do we need them. Now let's come back. Okay, so right now basically till we were only seeing how to create tables, how to understand tables, right? So now basically we are going to see something called as we are going to see the core foundations behind SQL. So SQL is made up of two things, right? So one is something called as relational calculus, and the other one is what we call as relational algebra. So you can divide SQL into two parts. One, you have relational calculus and relational. Like we'll see what is the use of what. It's the use of each. Now relational algebra, now basically both are formal query languages for relational databases. Now this is the foundation that was given by EF Code, right? EF Code is the founder of sequential databases, right? Now relational algebra. Now relation basically describes how to retrieve data step by step using operators. So now what is relational algebra? This is basically used. This is basically used to retrieve data step by step using operators. Now what is calculus? Calculus described basically how to compute, like what data we need. So the computation that we need to generate that data is determined by calculus, right? So if you say it in a very broad sense, so SQL has two parts. So you can split SQL as two parts. One is relational algebra, and the other is basically something called as relational calculus. So these two together form the basics of our SQL, right? Or the structured query language. Okay. Now, relational algebra again, as I said, relational algebra is basically the way we define is a formal query language associated with the relation model. Now, queries in algebra are composed using a collection of operators. A fundamental property is that every operator in algebra accepts. So I have two things whenever I'm doing with relational algebra. So calculus is related to computing. So this is going to compute, and this is the declarative or the step by step process how to reach to the result. Okay, so this is the actual basis of SQL, right? Uh, So relational algebra is a procedural query language used in the theory of relational databases. It defines a set of operations that take one or more tables as input and produces a new relation as an output. It tells the database how to get the result, not just what the result is needed. It's basically the step-by-step process of how should I get the result is nothing but called as relational algebra, right? And relational calculus is how we calculate the result, right? Is the computing part. Oh, sorry. The relational algebra is basically how the computing is going to happen. The relational calculus is basically logical. So this is basically going to wait. So I made a little bit of we got confused here, right? Let's get rid of these things. no, does that come? Something is okay. I can just scroll it up. So basically, we said SQL is two parts, right? So SQL has two parts to it. One is the relational algebra. Now this is basically our uh, data computation, right? This is how our computation is going to work. The other is basically something called as calculus, right? Now this is basically logical formulas to describe how the how the result will form. So calculus is basically the data specification, right? How should I reach to that uh, uh, result? So this is how my data computation is going to happen. And so okay, relational algebra basically it's a procedural how to retrieve data. Now calculus is basically non-procedural. Basically it is what data to retrieve, like what are we retrieving. It's basically logical based. Now this is like based on set theory. Output is going to be always a relation, right? A relation is again, as I said, a new relation is nothing but a table, right, that we are going to generate. Now it's like giving a recipe step by step and like stating the order at a restaurant. This is so for example, if you are at a restaurant, right? Oh, so okay, I guess now what he's trying to say. Now the step by step process, like, is our algebra, right? This is the computation that is going to happen, I guess. And then calculus is like uh, so relational calculus is, this is basically logical based. What does he mean by logical based? Is basically when I come to calculus, this is basically saying me what data should I get. So whenever you are going at a restaurant, right, you only see the menu, right? So this is, and you place an order to the, what happened to this? So if this is my restaurant, now if this is the restaurant, right? So here the, so when you come at the restaurant is the calculus part. Say what I need. The step by step implementation is going to be relational algebra, right? How it's going to happen behind the scene. Behind the scene mechanism is exactly the relational algebra. And then the calculus is basically we are just saying what we want. We are not saying how to compute it. The computation is going to be done by uh, also if you want to understand the speed, right? If I want us to understand how it's going to actually work, the speed and efficiency is determined is basically how can we express it in terms of relational algebra. So because yeah, to make it more precise, so relational calculus is just like English steps. English is like mentioning select star from. Now how this select is working is job of algebra. To get the result, so if I want to get a specific result, so if I want to uh, mention a specific so if I need say a specific tuple, right? First thing what I'm going to do is I'm going to declare the steps, or I'm going to say what dish I want. Now behind the scene, the chef knows, right, the recipe for the dish, but then only the chef knows how much time is going to take because he has the actual recipe in hand. So if I'm trying to optimize anything, then we need to work on our relational algebra, because so SQL is going to combine both of them to generate my result. Uh, so on SQL calculus is the SQL algebra, that is. Then why is it calculus though? Why is it named calculus? Why not? Calculus means basically a system of logical rules or formal expression, not mathem. Okay, not mathem. Basically, so in logical mathematics and computer science, the word refers to a formal system of representing statements. Also, this is some. So you see, calculus means a systems of. Behind the scene is the algebra that is taking care, right? Okay. So calculus word means a system of rules or formal framework used to reason about something. That is nothing but what calculus. Calculus means a system of rules or a formal framework used to reason about something. In logic and computer science, calculus means a system of rules or formal framework. It's basically, so if there is any rules, then we can say it as calculus. But it is not. It is different than the mathematical based calculus. Is he trying to say that the mathematical, it is something for calculating rates and areas, right? That is why. So the whole idea behind calculus was to calculate the mountain thing, right? Area occupied by the mountain. So then they came up in that. So basically, calculus is like a formal way of declaration how things are going to work, and the algebra is okay. Yeah, so that is how that thing is derived, right? Okay, so yeah, I guess that is all for this lesson. So basically, we studied ER, right? So ER is nothing but, first of all, let's stop our SQL because it's going to consume my computer a lot. Let's open. Yeah, every time I need to stop it, else because the thing is I forget that it's running, right? Let's let's go back. Let's do cd and let's say homebrew. Uh, is it brew MySQL stop, something like that? Brew services stop. So let's get rid of this, and instead of start, let's stop. Uh, yeah, wait. So every time, basically, this is my RDBMS that is running, right? Services. Oh, it has to be. I missed R. So I'm waiting for it to stop. Successfully stopped MySQL. Now if I try to run, what is cannot connect to server because it has been stopped, right? Okay. So now this is done. So yeah, I guess now does this work? This command is giving me a pain. I don't know. Every time I run it, it kind of, I'm not able to spin that. Let's do which code. No, I did add it to my uh well, that is something related to VS Code. This is view command palette. Yeah, I don't know. Every time it gives me this access. Every time I have to keep on overriding it. Why? What's this? Now let's do view command. Where is that disappeared now? Control Shift P. Let's close this. Now let's open again. And now it should be there. But it is getting unlinked too often. I don't know why. Yeah, so now it should work. So if I come here and do VS Code spin up, let's allow this. Okay, so yeah, so I guess yeah, that is all. Basically, we saw that SQL has two things, right? One is a relational calculus, that is the declaration or the thing that we take to the chef, right? Say we tell to the chef, you make this dish. The exact recipe is the chef that has it, right? That is nothing but my relational algebra. So I guess this is all for this session. I hope you guys liked it. I'll see you guys in the next one. Till that time, take care and bye bye.